we want to evaluate the integral of sine of ln of s ds. Now guys, the first step you want to take is you want to try to use u substitution. But guys, if we use u substitution, you're going to find out that we won't be able to cancel out all the values of s inside the integral, because the reason we always use u substitution is because we always want to try to cancel out all the s. If you take a look at this, if you use u substitution, that is, if you say u equal to ln of s, then if you take the derivative of u, which is du, this is going to be 1 over s. As you can see, guys, we are still having s inside the integral, so meaning we can't use u substitution. Okay, so we're going to use another integration technique. Okay, guys. So now guys, we are going to use integration by parts to evaluate this integral. Okay, so the formula is uv minus vdu. Okay, guys. So make sure you pay close attention to this solution. It is very, very important. Okay. So now guys, we are going to find the value of u and the value of v. Also, we are going to find the value of du. Now we are going to pick the value of u. That is the value that is very, very easy to take is derivative. Okay. But guys, what we're going to do here is we're going to say u is equal to the values inside the integral. That is sine of ln of s. Okay. So we're going to take the values inside the integral as u. So now we're going to call the remaining values as dv. Okay, so dv is going to be 1 ds because we're having an invisible one here. Okay, so this is going to be 1 ds, which can also be written as ds. So dv is equal to ds. So guys, we're going to take the derivative of u. This is going to give us du is equal to, we are going to use chain rule to take this derivative. Okay, and we know that chain rule says we're going to take the derivative from the outside function, that is starting from the outside values, then we're going to move to the inside values. Okay, so this derivative is going to give us cosine of ln of s. Then we also need to take the derivative of the inside function, which is ln of s. The derivative of ln of s is going to give us 1 over s. So guys, we can write this as divided by s. Okay, ds. Now if we take the integral of 1, the integral of 1 is going to give us s, right? So v is going to be equal to s. Okay, guys. So now we're going to plug these values inside the integration by part formulas. Okay, guys. So what is u? U is sine multiply ln of s. Then what is v? V is s. So this is s multiply sine of ln of s. Then minus the integral of what is v, guys? V is s. So this is s multiply what is du? Du is cosine of ln of s. Then divide s ds. As you can see, guys, the s are going to cancel out. But guys, we still have ln of s. That is, we are still going to take the integral of cosine of ln of s. So meaning we are going to use another integration by parts to evaluate the integral. Okay, so we're going to use the same logic. So we're going to say uv minus integral of v du. So we're going to say u is equal to cosine of ln of s. Okay, now we're going to call the remaining value dv. So this is dv is equal to ds. Okay, because we're also having an invisible one here. So dv is equals to 1 ds, which we can also write as ds. So I have to take the derivative of u. Okay, so this is going to be du is equal to, so guys, we're also going to use chain rule to take the derivative. So using chain rule, this is going to be negative because derivative of cosine is always negative sine, while derivative of sine is cosine. So because we're having cosine, this is going to be negative sine of ln of s. Okay, so you need to leave the inside value the way it is. Okay, then you're going to multiply this by the derivative of the inside value, which is derivative of ln of s is going to give us 1 over s. So this is divided by s ds. So if we take the integral of 1, it's going to give us s. So we're having v is equal to s. Okay, guys. So this is going to be, now guys, make sure you don't forget this. We're having s multiply sine of ln of s. Okay, so this is s multiply sine of ln of s. Okay, then minus, so guys, let's open a bracket here. So this is going to be, what is u, guys? U is cosine of ln of s, okay? Then multiply by v. What is v? V is s. So this is s multiply cosine of ln of s. Then minus the integral of v. What is v? V is s. Then multiply du. Du is negative sine ln of s over s, right? ds. But guys, you need to know that we're having negative. So this negative is going to multiply the negative outside the integral. So negative and negative is going to give us positive. So this is positive instead of negative. Okay? So guys, we are going to evaluate this as s sine ln of s, then minus. So we are going to multiply everything inside the bracket with the negative. So this is going to give us negative s cosine ln of s. So negative times positive is going to give us negative. So this is negative. The integral of s multiply sine of ln of s, okay, sine of ln of s over s ds. Now guys, this is where you need to pay close attention. Now guys, these values, this is equal to the integral of sine of ln of s, right? This is the integral of sine of ln of s ds is equal to these values, right? Now guys, if you take a look at this value, we're also having s multiply sine of ln of s over s. Now guys, the s are going to cancel out, okay? So the s are going to cancel out. So we are also having the integral of sine of ln of s, meaning we arrived at the initial integral we started with. We arrive at the initial integral we started with, meaning we are going to take this integral, we are going to move it to the right side, okay? And because this is negative, the integral of sine of ln of s, if we move this to the right side, this is going to be positive integral of sine of ln of s, okay guys? So if we add two of these, we are going to have 2 multiply the integral of sine of ln of s ds, okay? So make sure you take note of this. So this is going to be 2 multiplied by the integral of sine of ln of s. So this is now equal to s multiply sine of ln of s, okay? Then minus s multiply cosine of ln of s. So guys, what can we do now? We can basically divide both sides by 2 so that we can make this integral stand alone. As you can see, the two are going to cancel out. So we now have the integral of sine of ln of s. So this is basically equal to s sine of ln of s minus s multiply cosine of ln of s all over 2. So guys, this is going to be the answer to the first question, okay? So you need to use critical thinking whenever you want to solve a question like this, okay? So let's move to the next question. I don't want to waste much time here. I'm going to solve this within 30 minutes, okay? So I don't want to waste too much time. So let's try to solve the second question, okay guys? So let's take a look at the second question. So let me try to erase this off so that we can have enough space to solve the second question. Okay guys, let's take a look at the second question as quickly as possible. So the second question is, we want to find the integral of ds over s multiply the square root of s squared minus 4. Okay, now guys, if you try to use substitution, you won't be able to evaluate this integral. So we're going to use trigonometric substitution. Now you need to know that whenever we have s squared minus a squared, whenever we have s squared minus a squared, s is going to be equal to a secant theta. Okay, as you can see, guys, we're having s squared minus 4 squared. So meaning this is going to be s is equal to, what is a? A is going to be equal to 2, because 2 squared is going to give us 4, right? So s is going to be 2 multiplied secant theta. Now we need to take the derivative of s with respect to theta. Okay, so this is going to be ds is equal to, derivative of 2 secant theta is going to give us 2 secant theta tangent theta d theta. Okay, so guys, you should know this by now. So this is equal to 2 secant theta tangent theta d theta. Now guys, we're going to plug these values inside the integral. So let's do this as quickly as possible. Now guys, we know that this can also be written as 1 over, what is s? S is 2 secant theta, right? So this is going to be 2 secant theta, then multiplied by the square root of s squared minus 4. What is s, guys? S is 2 secant theta, so this is going to be 4 secant squared theta, okay? Because we're having s squared, 4 secant squared theta, then minus 4. What about the theta, guys? What about, sorry guys, not the theta. What about the s? The s is 2 secant theta tangent theta d theta. So guys, these two are going to cancel out, okay? And secant theta is going to cancel out secant theta. So we now have the integral of tangent theta divided by the integral of tangent theta, right? Divided by the square root of, now guys, as you can see, 4 is common on both sides, so meaning we can factor out 4. So doing this, we're going to have 4 multiply secant squared theta minus 1. Okay, so make sure you don't forget to include the theta. Okay guys, so this is going to be the integral of, this is tangent theta over, now guys, the square root of 4 is going to give us 2, right? So this is 2 multiplied by the square root of secant squared theta minus 1. This is equal to tangent square theta. You need to know your trigonometry properties, guys. Okay, so using your trigonometry property, you're going to find out that secant squared theta minus 1 is equal to tangent square theta. As you can see, guys, the square is going to cancel out the square root. So we now have tangent theta over 2 multiplied tangent theta. As you can see, guys, tangent theta is going to cancel out. Okay, so we now have the integral of 1 over 2 d theta. So we're going to take the integral of 1 over 2 with respect to theta. So the integral of 1 over 2 with respect to theta is going to give us 1 over 2 theta. Okay, so this is going to give us 1 over 2 theta. Now guys, you need to include your constant c. Sorry guys, in the first question I forgot to include the constant c. So make sure you always try to include the constant c, because we are dealing with indefinite integrals. So you always need to try to include your constant c. Guys, make sure you don't stop here. You always need to replace the value of theta. Okay, you always need to replace the value of theta. And we know that s is equal to 2 secant theta. Okay, so we're going to solve for theta. So we have to divide both sides by 2. So we're going to have secant theta is equal to s over 2. Okay, secant theta is equal to s over 2. So this is going to be theta is equal to secant inverse of s over 2. Okay, so we're going to replace the value of theta with secant inverse over s over 2. Okay, so this is 1 over 2, then multiply secant inverse of s over 2 plus c. So guys, this is going to be the final answer to this question. Okay guys, so let's quickly take a look at the next question. Okay, so we are done with the first 2 questions. So let's try to solve the remaining 2 questions. So I want to do this as quickly as possible, because I don't want to spend 60 minutes solving calculus questions. No. I want to solve this as quickly as possible. So let's take a look at the third question. So what does the third question says? So let me get my pen. So this is question 3. So we want to evaluate the integral of 1 over 5 minus s squared ds. Now guys, if you try to use this substitution, you're going to find out that you are still going to have the value of s inside the integral. So we are going to use partial fraction decomposition. So using partial fraction decomposition, we are going to replace the numerator with variables. Okay, so this is going to be a over. Now we are going to take the square root, or sorry guys, we are going to take the we're going to take the square root on the denominator. So this is going to be the square root of 5 minus s. Okay, because if you take the square root of s squared, it's going to give us s. Okay, then because we're having two values on the denominator, meaning we are also going to have another variable, which is b. So this is going to be plus b over the square root of 5, then plus s. Okay, so now guys, we are going to use lowest common factor. So this is going to be 5 minus s squared on the denominator. Then if we evaluate this on the numerator, we are going to have a plus b multiply the square root of 5. Then on the second values, we are going to have a minus b, then multiply s. So guys, I want to try to solve this as quickly as possible. Okay, now guys, we are going to take a look at the values or the coefficients on a plus b and a minus b. Okay, so this is a plus b. Guys, this is going to be equal to 1 over root 5. Okay, if you take a look at the coefficients, or if you take a look at the values representing a plus b, you're going to find out that this is going to be 1 over root 5. Then a minus b is going to be equal to 0, because if you take a look at a minus b, we don't have any constant number. We only have s, so this is equal to 0. So guys, if we evaluate this, we're going to find out that a is equal to b, which is equal to 1 over 2 root 5. So we're going to place the value of 1 over 2 root 5 in place of a and b. Okay, and because these values are similar and this is a constant value, meaning we are going to take this value outside the integral. Okay, so this is going to be 1 over 2 root 5, then multiply by the integral of 1 over, so this is 1 over root 5 minus s. Okay, then plus 1 over root 5 plus s ds. As you can see guys, we can easily take the integral of this. Okay, now we can easily take the integral of these values. So this is going to be 1 over 2 root 5, then multiply. So this integral is going to give us negative ln of the absolute value of root 5 minus s. Okay, so this is for the first integral. Then for the second integral, this is going to give us positive ln multiply by the absolute value of 5, positive ln of the absolute value of root 5 plus s. Okay guys, so this is going to be the value. Now guys, we can also write this as 1 over 2 root 5, then multiply ln of the absolute value of root 5 plus s, then minus ln of the absolute value of root 5 minus s. Okay, so guys, now guys, this can also be written as 1 over 2 root 5, then multiply ln of root 5 plus s divide root 5 minus s, because we're having subtraction of functions. Okay. So this is plus c. So guys, this is going to be the answer to the third question. So let's quickly take a look at how to solve the last question. Okay, so let's solve the last question. So let me do this as quickly as possible. Like I said, I don't want to spend 30 minutes solving calculus questions, and I hope you guys understood everything. So let's solve the last question. So the last question is, we want to find the area of the shaded region. So we're having y is equal to 1 over s, and y is equal to 5 minus 2s over 2. So guys, the first step you want to take is you want to find the critical point. Okay, sorry guys, you want to find the root, not the critical point. You want to find the root of this function, okay? Because we want to find the shaded area, right? What do we mean by area? Area, this is basically integration from one point to another point, okay? So we're going to integrate from a lower point, we're going to move to a higher point, or we're going to integrate from a higher point to a lower point. So this is what we know as area. So integration, this is basically area, okay? So we are trying to find the area of the function. So whenever we are integrating a function, we are always trying to find the area of that function. So this is what we know as integration. So let's quickly take a look at this. So we're going to equate the y values. So this is going to be 1 over s is equal to 5 minus 2s over 2. So we have to solve for the value of s, okay? So this is going to be the root, okay, guys? So we are going to cross multiply. This is equal to 2 is equal to s multiply 5 minus 2s, okay? So this is going to give us 2 is equal to 5s minus 2s squared. So this is going to be equal to 2s squared minus 5s plus 2 is equal to 0. As you can see, guys, we are now having a quadratic function. So we're going to use the quadratic formula, which says minus b plus or minus the square root of b squared minus 4ac divide 2a. Okay? So, guys, we are going to find the value of a, the value of b, and the value of c. And, guys, the value of a is 2, the value of b is negative 5, and the value of c is 2. So, guys, I'm not going to solve this. You can easily solve this. So all you need to do, you just need to plug the values of a, b, and c into the formula. Doing this, you'll be able to find the root. So solving this, we are going to get the s values as 2 or 0.5. Okay? So now, guys, this is going to be the limit of integration. So we're going to start from 0.5, then we're going to move to 2. Okay? So this is going to be the integral of, sorry guys, the integral from 0.5 to 2. Now, guys, this is going to be g of s minus f of s. So we're going to subtract the first function from the second function. Okay? So this is going to be 5 minus 2s, 5 minus 2s over 2. Okay, guys? Then minus 1 over s. 1 over s ds. Now, guys, we can easily find the area. Okay? So the first value, which is 5 minus 2s over 2, we're going to use substitution to evaluate this integral. Okay? So we're going to say u is equal to 5 minus 2s. Then we're going to take the derivative of u with respect to s. So this is du is equal to negative 2 ds. Okay? So ds is going to be equal to negative du over 2. Okay, guys? So we're going to plug this inside the integral. So it's going to be the integral. So this is from 0.5 to 2. So, guys, instead of 5 minus 2s, we're going to write u, then over 2, right? Then what is the s? The s is negative du over 2. So this is multiplied by negative du over 2. As you can see, guys, we are having a constant inside the integral. Meaning we're going to take this constant outside the integral. And we're also having negative. So we're going to take the negative outside the integral. So this is going to be negative 1 over 2 multiplied 2 is what? Is 4, of course. So this is 1 over 4. Then multiply by the integral of u. Okay? So, guys, what is the integral of u? The integral of u is 1 over 2 multiply u raised to the power of 2. So this is 1 over 4 multiply 1 over 2, then multiply u raised to the power of 2. So, guys, this is for the first integral, right? So this is for the first value. So this is going to be negative 1 over 8, then multiply u raised to the power of 2. So make sure you always replace your value of u. Always replace your value of u. So this is negative 1 over 8, then multiply. What is u, guys? U is 5 minus 2s, then raised to the power of 2. So, guys, this is going to be the first integral. Now, for the second integral, which is the value of negative 1 over s, right? So the integral of 1 over s is basically ln of s. Okay, ln of the absolute value of s. Okay, guys? So this is going to be negative. So let me put this with black. So this is going to be negative ln of the absolute value of s, guys. Now we are evaluating this from 0.5 to 2. Okay, guys? So, guys, you can easily evaluate this. It is very, very easy. So all you need to do, you just need to plug your upper limit, then minus the lower limit. Okay, guys, so you need to plug your upper limit minus the lower limit. Okay, guys, so this is negative 1 over 8. Then multiply 5 minus 2, multiply 2. Okay, so this is for the upper limit. Then raised to the power of 2. Then minus ln of 2. Okay, so whenever you see s, you are going to plug 2. So this is for the first value, that is the upper limit. Then minus the lower limit. So this is going to be negative 1 over 8. Then multiply 5 minus 2. 5 minus 2 multiply 0.5. Okay, so this is for the lower limit. Then raised to the power of 2. Okay, guys, raised to the power of 2. Then minus ln of 0.5. Now, guys, you can easily use your calculator to get the answer. So using your calculator, you're going to find out that the upper limit is going to give us negative 0.825, and the lower limit is going to give us positive 2.7. So, guys, negative 0.825 plus 2.7 is going to give us 1.875. So, guys, this is going to be the area of the shaded region, 1.875 square units. So this is 1.875 square units. So guys, this is going to be the answer to the fourth question. So these are the solutions to the questions. So guys, if there is any of you who has not subscribed to this channel yet, click the subscribe button below. And if you want me to make more videos like this in the future, try to share this video with your friend. And if there is any question you want me to solve, make sure you tell me on the comment section below. I will try my best to answer all your questions. So guys, for the calculus students, these are the solutions to your final exam questions. So this question took me less than 40 minutes. So these questions are really easy, but if you don't understand the logic, it's going to be very, very difficult to solve. So you need to use critical thinking whenever you want to solve questions like this. So guys, these are the questions. So if you are watching my video for the first time, click the subscribe button, share my video with your friends, click the like button, like my video. Also click the bell notification icon below so that you can get notified whenever I upload a new video. And guys, before I forget, I have a full course on calculus 1 and calculus 2. If you really want to learn calculus 1 and calculus 2 and be a master of calculus 1 and calculus 2, click the link in the description box below. This course is very, very cheap. This course costs just $5. Okay, guys? So with $5, you can get access to my full course on calculus 1 and calculus 2. So click the link in the comment section below. You get access to my full course for just $5. See you all. Bye.